Here we are going to present the research Integrated Traffic Management System for Safe and Sustainable Mobility. This research is conducted by the Transportation Engineering Laboratory in the Department of Civil Engineering. This project is funded by the World Bank through AHEAD operations for a period of 3 years. We have our team leader Professor Niranga, Amarasingha and few supervisors and mentors. Also, 5 MPhil degrees are targeted from this project. We have 4 main tasks in this study. Each task will be described in this video. Task number 1. Developing a vehicle count sensor using image processing.
Introduction. Traffic count sensor developed using image processing algorithms to collect vehicle category-wise turn-in movement count prediction in an intersection. Implementation performed using Python programming language. Case study at Malabe Kaduvela Road. First step is camera installation. Traffic video data collection started by installing an IP camera in front of slit near Valivity intersection. Second step is development of algorithms for image processing. Third step is collection of vehicle counts using video. Graphical user interface used to collect vehicle counts in a video. And Raspberry Pi board used to collect real-time vehicle count. And finally, use of data for traffic management. Results. LSTM neural network developed to predict next hour traffic volume using a public dataset. R2 score value obtained is 0.92. CNN model as pilot study to classify vehicles according to turn-in movements such as left, right, through movements in an intersection. And vehicle count sensor calibrated to get vehicle counts for different videos.
Road traffic related forecast using deep learning.
In image processing method, segmentation techniques are used to count the number of vehicles. And the major issue in this method is it is unable to identify the coinciding vehicles separately from a video frame. That problem I demonstrate here by using this image. In this proposed methodology, it is not necessary to identify the vehicle separately in the video frame. When calculating average speed of the road, we have to calculate the distance of moving objects in 2 consecutive frames, and then we have to divide it by the time between 2 frames according to the video frame rate. By using that method, we can calculate the average speed of the road. Although there can be coincidence vehicle in the video frames, but according to this new method, that would not affect the accuracy of the speed calculation. The distance between the moving objects can be calculated by considering the correlation between 2 consecutive frames. From that correlation graph, we can calculate the distance of moving objects in 2 consecutive frames in pixels. And also, when I train my LSTM neural network, I hope to use this set of features and labels for 6 months as data.
Task number 2. Developing safety performance functions for urban intersections in Sri Lanka. Introduction. This task is focusing on safety at urban intersections. Crash frequency can be used as an indicator of safety at urban intersections. Usually, crash frequency is defined as number of accidents occurred during a year. Crash frequency can be predicted in terms of crash-related factors. That's called crash frequency modeling. By crash frequency modeling, an equation can be obtained. The dependent variable is crash frequency. Independent variables are crash-related variables. In this study, crash frequency was predicted in terms of intersection geometry and traffic-related variables. 2 safety performance functions were developed for urban intersections in Colombo district and Sri Lanka. Results of the task number 2. These are the developed safety performance functions for Colombo and Sri Lanka. Out of 35 geometric variables, only 6 variables were found statistically significant in Colombo District Safety Performance Function. Those variables are presence of left turn lanes on major leg, average shoulder width of major leg, presence of bus halting places, traffic controlling devices, illegal roadside parking and roads connected to minor leg. Then in the developed safety performance functions for Sri Lanka, 10 variables were statistically significant. Those variables were vehicle kilometers of travel, presence of left turn-in lanes on minor leg, right turn-in lanes on major leg, presence of traffic controlling devices, road rails, approach lanes in minor leg, median width of major leg, curbs in minor leg, road signs and roads connected to minor leg. Identifying those significant variables is a key contribution to the existing literature. Those are the main drivers of crash frequency at urban intersections. By identifying them, countermeasures can be proposed to minimize crash frequency. Also, countermeasures can be compared using the developed safety performance functions. Therefore, these safety performance functions are important in designing stage of urban intersections. Also, existing intersections can be improved using effective countermeasures. Therefore, this task number 2 contributes to increased safety at urban intersections in Sri Lanka. Task number 3, traffic management approaches through microsimulation.
One of the main reasons for delay of the passengers on their day-to-day trips is the traffic congestion at intersections and corridors. In order to minimize traffic congestion, Sri Lanka and foreign countries have been using microsimulation modeling to identify the most suitable traffic management solution. In Sri Lanka and foreign countries, microsimulation modeling has been done for either three-leg or four-leg intersections separately. Therefore, in our study, we are going to develop a generalized methodology which includes microsimulation modeling to model intersections and corridors with a combination of three-legged and four-legged intersections in any geographical region in Sri Lanka and identify the most suitable traffic management measure for the relevant intersections and corridors. The traffic management measures are fully signalization of the intersection and corridors, geometrical improvements, and the combination of signalization and geometrical improvements. We did microsimulation modeling and identified traffic management measures for the following intersections and corridors. The Malabar intersection could be improved by signal optimization with priority rules. Malavita intersection could be improved by increasing number of lanes with road widening. Sinek intersection could be improved by increasing the number of lanes with road widening from the Kadula approach. Kotalawal to Talawala to Pittukala corridor could be improved by increasing number of lanes with road widening, and the Pittukala to Malabar corridor could be improved by signal optimization with geometrical improvements.
Task 4, Real-time Q-length predictions at intersections in mixed traffic conditions. Introduction. Vehicle queue is a repercussion of traffic congestions that causes significant delay to the road users and are largely seen at intersections. This task is focused on the real-time vehicle queue prediction with live video capturing, which helps to enhance the accuracy of the predictions. Moving on to the methodology of the task. The methodology comprises of three main sections: data collection, data extraction, and data analysis. The data collection is based on the two intersection types, which are signalized intersections and unsignalized intersections. The data extraction is focused on the key variables considered in the task, and they are the queue length, arrival flow, discharge flow, vehicle type, traffic control, and other location related factors. The data analysis is focused on two phases: the statistical analysis and the neural network analysis. The statistical analysis is based on the time series analysis in the view software, and the neural network analysis is based on the long short-term method in the Python software. The results of the statistical analysis, as mentioned in the methodology, The statistical analysis was based on a time series analysis in order to develop a vector autoregression model. The vector autoregression model provides the Q at time t alongside the governing factors, which are the Q at the previous time sequences, the arrival flow and the discharge flow at the previous time sequences, and the signal at the present time. The model fit is further illustrated in the first figure as the Q estimation. And this Q estimation was based on the vehicle platoon, which is the slip pedestrian crossing in front of slip. This developed model was further applied to other multiple locations, and the second figure shows the Q prediction of the Armour Street junction, and the results show that the model accuracy in the Q estimation as well as the Q prediction is higher than 70%.
These are the publications of the year 2021. Thank you for listening.